I'm Anil Kumar. Welcome to my YouTube channel. As per the request of many of our subscribers, we have started developing a website, Global Math Institute, to provide you with organized list of videos. An attempt is being made. It will take some time to really get it going, but at present you can just test a part of it where we have linked about 5,000 videos. This video will be a resource for all the students all over the world, and the website will be free for all times to come for students to watch these videos. Now here we'll talk about speed, distance, time relationship. I've taken up 5 questions. We'll begin with the relation distance equals to speed into time and related questions. You can actually watch many other examples on distance, speed, time and related examples in different playlists organized in the website. You can always pause the video, copy these questions, answer them, and then look into my solutions. Let's begin with the basic relation, and then we'll take up these solutions one by one. So as you know, distance is speed into time. Easy way to represent this is in the form of a triangle. Distance is the product of speed and time, right? So this relation can be, T. So this relation can be written as distance is equal to speed into time, or we can write speed as a ratio of distance and time, or time in the ratio of distance and speed, correct? You have to, of course, take care of units while working with distance, speed, time problems, right? Now, conversion of units is, if I say that the speed is equal to, let us say, 120 kilometers per hour, and we want to convert this to meters per second, then how are we going to do it? So since we have 120 kilometers per hour, and we actually need meters, so we know that 1 kilometer is 1,000 meters. We have to cancel kilometers, right? We have to cancel hours here, so we have looking for hours and seconds relation, so which is 60 times 60 seconds. So that is how you are going to convert the units, right? So I hope that makes sense. We have taken a very simple example here, mainly to illustrate the process, right? So 60 goes 2 times, and here we can cancel this 0 with 0, 6 with 2, so we get 3. So what we get here is 100 over 3, and as far as the units go, you can see that hours and hours will cancel, and kilometer will cancel with kilometer. You're left with meters per second. Do you see that? So the units will be now meters per second. Now, if required, this relation can be written as a fraction, which is 33/1/3 meters per second, or it could be written as an approximate value as 33.3 meters per second to 1 decimal place. Perfect. So with this in mind, let us now begin with the solutions of the questions. The concept which you have seen here on the very first page will help you to solve all the 5 related problems. The very first question here is, find the time taken by a car to complete a journey of 400 kilometers with average speed of 80 kilometers per hour. Normally, we are going to use lowercase. For our variables, d is the distance, 400 kilometers, s is the speed, 80 kilometers per hour, and we need to find the time taken t, right? Relation, very clear. Distance, speed, and time. Since we want to find what time is, the relation is time is distance over speed, right? So that is how we are going to solve this question, right? So that is the base. Let's find out the time now. So time is equal to distance of 400 kilometers, speed of 80 kilometers per hour, right? So that can be simplified as 2, so we get 10 here, right? And dividing 10 by 2, we get 5. Let me write here, 5. The units, kilometer, kilometer cancel, right? So it is kilometers over kilometers per hour. So we get 5 hours. Does it make sense to you? Right? So a 400 kilometer distance will be covered in 5 hours. So the average speed is this, time taken will be in 5 hours. Distance of 400 kilometers will be covered at the speed of 80 kilometers per hour. Is that clear? Now this statement is normally used as a part of solution or the answer in any word problem. However, moving forward, we'll avoid it, right? So I may or may not explicitly write down the answer, but you need to mention it. Question number 2 here is, find the average speed of the car if it covers 180 kilometers at 60 kilometers per hour and further 120 kilometers at 80 kilometers per hour. So let's try to understand the situation. So what we have here is that the total distance is given to us, which is being covered at different speeds, right? So find the average speed of the car. If it covers 180 kilometers, let's say this is from here, distance 1 is 180 kilometers. At the speed of 60 kilometers per hour, right? And further, this distance is 120 kilometers, and this is being covered at 80 kilometers per hour. We need to find the average speed, right? So we need to find average speed. Is that clear to you? Correct? I'd like you to pause the video and answer this. I hope the concept is clear, right? So we know the total distance, we can write total distance, which in our case is 180 plus 120. Right? So it is 300 kilometers. We need to find the time taken, right? So let's say that the time taken for first part of the journey is t1 and for the second part is t2. Right? Then t1, time taken in the first part of the journey, is distance divided by speed. So it will be 180 kilometers per hour divided by 60 kilometers per hour, and that clearly gives you 3 hours. And the second duration of time is 120 kilometers per hour divided by 80 kilometers per hour. And that gives you can divide both by 4, so we get 3 over 2 hours or 1.5 hours. So the total time for us is how much? Three plus 1.5, so we have 4.5 hours. Now, we know the relation distance, speed, and time. We are repeating this process so that you can always remember it, right? So we need to find the average speed this time. So we have average speed, which is total distance over total time. So in our case, it is 300 divided by 4.5. Correct? So that is how you are going to answer these questions. Now sometimes the calculator may not be required. So this calculation to do, you could also write this as 3000 over 45 and then do the needful. So we can cancel by 5 goes 9 times, and 5 600. This can be divided by 3, so 3 times 3 and 200, right? So we get average speed of 200 over 3, which could be written as 3 times 6 is 18, again 20, 66, 1 over 3 kilometers per hour. Is that clear to you? So that is how we are going to solve this particular question. You will note that the speeds were 60 kilometers per hour and 80 kilometers per hour. However, the average is more towards 60 kilometers per hour since larger distance was covered at that speed, right? So it is an example of weighted mean, right? A word of caution is that you should not just add the speed and divide by 2 and find their average. You have to work it as a weighted mean question. Perfect. Let's move on and take question number 3 now. Here we'll practice unit conversion. We need to convert 80 kilometers per hour to meters per second, right? So let's do it. So we have 80 kilometers per hour. So 1 kilometer, we have to cancel kilometers, right? So we know 1 kilometer is 1000 meters. As far as the hour is concerned, it is 60 times 60 seconds. So from here, you can see that the units match. We are left with meters per second. Perfect. The numbers, let's cancel whatever we can. So 2 zeros, right? Okay. Now with 6, 2 times 3, that goes 4 times. And this 2 times, and with this goes 3 times. So we get 9, right? So after this, we can write down this as 200 meters over 9 seconds, or 9 times 2 is 18, and then again 2, and so we are left with 2 as a remainder over 9 meters per second. So that becomes the answer in meters per second. So I hope the steps are absolutely clear, right? The next one here is we need to convert now 0.015 centimeters per second to kilometers per hour. Is that clear to you? To the conversion. So we have 0.015 centimeters per second. Now we need to convert centimeters to kilometers. Okay, how can we do that? Well, we know that 1 kilometer is equal to 1000 meters and then 100 centimeters. Does make sense to you? So you could do like this, correct? As far as seconds are concerned, we're looking into hours in the denominator. So 1 hour is 60 times 60 seconds. Does make sense to you? So that is easier to convert, right? So I hope this step is absolutely clear. Now cancel out and ensure that you get the units which are required, right? So we could write this as 0.015. We got unit here, kilometers. This is 60 times 60 over 1000, 100 or 100,000. 100,000, correct? Units, kilometers per hour. So we got the required units. Now, let's simplify. So 2 zeros cancel. Now let us also try to understand how to do this calculation, right? So what I'm going to do here is, first I'm going to multiply by 6. 6 times 5 is 30. 6 times 1 is 6, and then 3 is 9, right? So we get 0.090, and we have to still multiply by 6, and we have to divide this by 1000. Is that clear to you? So now when I multiply by 6, 6 times 9 is 54, so we get 0.54 over 1000, while the units are kilometers per hour. So we could now write our answer in standard form, right? So you could say it is 0.54 into 10 raised to power minus 3, but in standard form or in scientific notation, it should be written as 5.4. So we change the decimal, right? Into 10 to the power of, this time now, minus 4 kilometers per hour. Does it make sense to you? So this is a very important step. So what we did here, we wrote So what we did here, that we wrote it in scientific form. You may be required to write some answers in scientific form, and you may also be required to do the calculations without the calculator. So this exercise really helps you to perform that. I hope that makes sense. So let's move on and take the next question now. Let's take up question number 4. Two trains are approaching each other on parallel tracks at a speed of 80 kilometers per hour and 120 kilometers per hour respectively. How long will it take them to cross if they are 240 kilometers apart? So let's look into the situation. Let's say this is the total distance, which is 240 kilometers, correct? So that is the distance. Now one train is moving much faster than the other, so let's say they cross somewhere here. And we're saying that this is coming at the rate of 120 kilometers per hour, and the other one is at 80 kilometers per hour. And let us say that the time taken is t. They will of course travel for the same time, correct? So if you know speed and time, you can find the distance, correct? So we are saying let this distance be d1 and this distance be d2, right? And we are again going to use the same relation, distance, speed, time. For convenience, let me just write distance, speed, and time, right? So we can say that distance d1 traveled by the first train will be speed into time, which is 120t kilometers. Distance d2 will be speed into time, which is 80t kilometers. And since we know that the total distance is 240, we can now write 120t plus 80t equals to 240. Now that is 200, right? So t is 240 divided by 200. The units, of course, kilometers and hours, right? So kilometers and kilometers cancel. So we have time in hours. So T is equal to, we can now simplify this, right? So dividing by 20, we can write this as 1.2, right, hours. Does make sense. Now, if you get this answer as 1.2 hours, it is a good idea to write it in hours and minutes, right? So remember, it is 1 hour and 0.2 times 60 minutes, right? So you can write 1 hour, and when you multiply this by 2, you get 12 minutes. So we'll write our answer as, they will meet in an hour and 12 minutes. Does it make sense? So that is how we should be writing our answer. Okay? The last question here is question number 5. How long is the train which passes a tree in 10 seconds at a speed of 120 kilometers per hour? Well, this is a very interesting question. So what we have here is, let's say there's a tree here, right? And the train passes. So let's say train approaches, right? And the whole length moves away. So that means in 10 seconds, length L of train is covered at the speed of 120 kilometers per hour. Does it make sense to you? Correct? So that is what such questions really mean. So we can again find the distance traveled. So length L is speed into time, right? So length L is speed into time. So in this case, the speed is 120 kilometers per hour, but the time is in 10 seconds. So we have to now convert the units and then get our solution. So we get 120. Let's write this in meters, right? So we have kilometers. We'll write this as 1000 meters, right? So we can write this as, let me write here, kilometer first. In a different ink, let me write 1000 meters is 1 kilometer. Is that okay? Now, hours will be 1 hour is 60 seconds. 60 times 60 times 60, right? 60 times 60 seconds. And here we have already 10 seconds. Is that clear to you? So that is how we can reorganize. Perfect. So see the units first. Kilometers, kilometers, hours cancel. Seconds and seconds also cancel. Now let's look into simplification. So this 10 goes with 1 0, the other 0 goes with this. And what we have here is 12 over 6 times 6, which is 36, times 1000 meters, right? So 12 goes 3 times, right? Now dividing 1000 by 3, so 3 times 3 is 3, 10 again, 3, and then again 3, 1 over 3 meters. Do you see that? So that is how we get our answer. And therefore, we can write our answer as length of the train is 3331 over 3 meters. Does make sense to you? So that is how we should be answering this question. So once you understand the techniques, you can always apply some shortcuts to find the answers much faster. So in this video, we learned basics about speed, distance and time. We had 5 questions, and these are very important 5 questions. They overall cover the whole topic. We have seen how to convert the units, write them in exact form, write them in scientific notation, and we have also seen how to solve word problems related to distance, speed and time. Now at my website, you'll have at least 100 questions solved on this speed, distance, time. You may have to look into more than one playlist for the same. So I hope that will be an enjoyable experience. I'd like you to share your experience, write comments as you have been doing, and thanks for your time. Thank you.